Let us do one case study, students. So for 2 variable case, 3 variable case and 4 variable case, let us do case study, and this is what the conclusion we'll see. We'll understand what this conclusion means, and this is very useful. Okay. So let's say if I'm dealing with a 2 variable case, so this is A and this is B. So I want to find XOR of A XOR B, and I also want to find XNOR of A XOR B. So because if you have two inputs, so you can have 4 input combinations, right? So you have 0 0, 0 1, 1 0 and 1 1. So you have 4 input combination 0 0, 0 1, 1 0 and 1 1. So the input is 0 0, output is, so XOR we have seen already, right? 0, this is 1, this is 1 and this is 0. For XNOR, you see this is 1, this is 0, this is 0, this is 1. We have already understood this. So here I can see this column and this columns are complement to each other, because if you take 0 complement 1, 1 complement 0, 1 complement 0 complement 1. So what can I say? That A XOR B is equivalent to complement of A XOR B. So this is what is the point I have written, or you can write in the reverse way also, that is A XOR B is equivalent to A XOR B complements. This one. So both are correct. Let us extend the same analysis for a 3-variable case. Okay, so in a 3-variable case, you have to write for A, B, C combinations. If you do that, so this is, let's say A, this is, let's say B, this is, let's say C, and then you find the XOR of ABC, and then you find the XNOR of ABC. Okay, so because you have 3 variables, how many combination you can have? You can have 2 power 3, 8 number of possible combinations. So let us write the combination 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and finally you have 1 1 and 1. Okay, so this is what is the possible input combination. Okay, but here, I mean, if I'm finding what is this XOR, that means I want to find what is 0 XOR 0 XOR 0. So remember the property XOR gate produces output 1 when odd number of inputs are 1. So in the input combination, you should have odd number of 1s. Output is logic 1 if there are odd number of 1 present in the input combination. So every time you need to count how many 1s present in the input side. So in the first case, so there are 0 number of 1 produced in the input. So 0 is a even number. So answer is 0. You need odd number of 1. So here odd number of 1 condition is not satisfying. So the answer is 0. Second combination, we have 1 1, right? So 1 is a odd number, output is 1. Next 0 1 0, again you have only 1 1. So 1 is odd number, so answer is 1. Next case 0 1 1, you have 2 number of 1. So you need odd number of 1, but here it is even number of 1. So answer is 0. Next case 1 number of 1, answer is 1. Next case again even number of 1, 0. Next case again you have 2 number of 1. So answer is again 0. Lastly it is 1 1 1. So odd number of 1, 3 number of 1, answer is 1. So this is how the XOR gate is. And XNOR gate case, students, we understood the property is there should be even number of 0 on the input combination so that output can be 1. So if you check it out, how many number of 0 are there in the input combination? So you need even number of 0. So here you see it is odd number of 0, but your requirement is even number of 0. So even number of 0 is there, means output is 1, else it is 0. So in the first case you don't have even number of 0, output is 0. Second case you have 2 number of zeros, so it's a even number, so answer is 1. Next case you have 0 and 0, so it is again even number of 0, answer is 1. Next case it is only 1 0, so it is a odd number, it is not going to happen. In this case you have 2 number of 0, answer is 1. Next case 1 0, answer is 0. Next case also it is 0. Next case you have 0 number of 0, so 0 number of 0, so it is answer is 1, because you need even number of 0. How many 0 are there? 0 number of 0 are there. 0 is even number, yes, so answer is 1. So you observe, students, like in this case we said that XOR and XNOR are complement to each other in the 2-variable case. But if you see this column and this column, if you make the comparison, so you see it is exactly same. So the conclusion is then A XOR B XOR C is equivalent to A XNOR B XNOR C. A XOR B XOR C is equivalent to A XNOR B XNOR C. So in a two variable case, XOR and XNOR are complement to each other. But in a three variable case, if you find XOR and XNOR, they are same. So this is what is the point I have written here. But if you go with four variable case, students, I'll not give you the all the 4 2 power 4 16 combination, but few rows let me show you, and you can easily visualize the things actually. So this is A, B, C, and D. So using this, we'll be finding what is XOR and what is XNOR. So let me try this for a couple of rows. Okay. So 0 0 0 0 0 0 0 1. You take any arbitrary combination 1 0 1 0. You can take 1 1 0 1. You can take 1 1 1 0. Okay, or any combination you take. If like I don't want to waste time, so that's why I'm not taking all the 16 combination. So you can take all the 16 combination, but the logic is same again. So for XOR, so you need to count whether odd number of 1 are there or not. For XNOR, you need to count whether even number of 0 are there or not. In the first case, there are 0 number of 1. So 0 is a even number. I need odd number of 1. So answer is 0. Second case, you have 1 number of 1. 1 is a odd number. Yes, answer is 1. Next case, so here you have 2 number of 1. 2 is a even number. You need odd number of 1. So answer is again 0. Next case 1 1 0 1. So you have 3 number of 1. So you need odd number of 1. Yes, I have 3 number of 1. Answer is 1. Next case also 3 number of 1. Answer is 1. But if I'm going with XNOR case, you see that first case you have 4 number of 0. 4 is a even number. Yes. So answer will be 1. Next case 3 number of 0. So 3 is a even number. No. So answer is 0. Next case 2 number of 0. So 2 is a even number. Yes. Answer is 1. Next case 1 0, answer will be 0. Next case 1 0, answer will be 0. So if you observe, students, if you compare this column and this column now, you see they are complement to each other. 0 become 1, 1 become 0, 0 become 1, 1 become 0, 1 become 0. So what is the point then? Then this column and these columns are complement to each other. They are not same the way it is happening in this case. So what can be said? Then I can say that A XOR with B, XOR with C, XOR with D, complement if I take, so I'll get this is A XNOR B XNOR C XNOR D. I mean complement of this column is this column. So that is what is the point written here. This one. And you again do the same thing for 5 variable A, B, C, D, E. So what you are going to see is again this pattern will be followed there. That is your A XOR B XOR C XOR D XOR E will be same as A XNOR B XNOR C XNOR D XNOR E. You want to check, you check for any combination. Let's say you are taking 1 0 1 1 0. Okay, or you take 1 1 0 1 0. So A B C D. So if I ask you what is the XOR of this and what is the XNOR of this, so what it will be? So if I am finding the XOR, odd number 1 are there? Yes. Odd number 1 are there means answer is logic 1. So for XNOR case, whether even number of 0 are there? Yes. So answer is logic 1. That means for this combination, if I am finding XOR and XNOR, they are same. So same is the story for this also. You see odd number of 1. So XOR output is 1 and XNOR output will be again 1 because even number of zeros. Yes or no? So this is how it is. So XOR and XNOR are complement to each other. So if even number of variables are involved, but XOR and XNOR will be same if odd number of variables are involved. So for 3 variable case, 5 variable case, 7 variable case, so always you will be getting this kind of relations. So XOR and XNOR will be same. But for even variable case, that is for 2 variable case, 4 variable case, always you will get the complement relations. So popularly we say XOR and XNOR are complement to each other if even number of variables are involved. XOR and XNOR are same if odd number of variables are involved. So this is the statement I have written. XOR and XNOR are complement to each other when even number of variables are involved. However, they are same for odd number of variables. And one more point, students, you need to understand. So for a two variable case, if I ask you how many min terms, how many max terms, you have two min terms and two max terms. Even here also two max term, two min terms. In a three variable case, if I ask you, you have four min terms and you have four max term, this, and this, this and this. Similarly, if you write all the 16 combination for four variable case, you will understand there are 8 min terms and 8 max terms. If you are writing for 5 variable case 2 power 5 32 combination, you will see there are 16 min terms and 16 max terms. So the point is, in XOR as well as in XNOR, in both XOR and XNOR, so number of min terms is equals to number of max terms. Using n variable, total we have 2 raised to power n number of combination. Out of 2 raised to power n number of combination, half of this, that is 2 raised to power n by 2 will be number of min terms, 2 raised to power n by 2 will be number of max terms. 2 raised to power n by 2 is nothing but 2 raised to power n minus 1. So using n variables, you can have 2 power n number of combination. Out of 2 power n number of combination, 2 to the power n minus 1 number of combination will have min terms and these many max terms. So in an n input XOR gate or XNOR gate, the number of min terms is equals to number of max term, which is 2 raised to power n by 2 and equals to 2 raised to power n minus 1. Such kind of functions are also known as neutral function. Neutral function is something where number of min terms equals to number of max terms. So XOR gate and XNOR gate, sometimes they are also known as neutral functions, keeping in mind that number of min terms equals to number of max terms. So this is one of the interesting properties, friends. And this is a 5-star I am giving. You just memorize the standard results actually, okay? So for a 3 input case, 1, 2, 4, 7 is the min terms or 0, 3, 5, 6 is the max terms. So for A XOR B XOR C, very popularly in full adder, full subtractor, in many different applications, this A XOR B XOR C is used. So that time, to reach to this point, so you have to spend 5-10 minutes of time. So always you remember this is standard data, repeatedly use model. So A XOR B XOR C, the min term is 1, 2, 4, 7. From where this 1, 2, 4, 7 is coming, you observe this one. So if I ask you what is the min terms of this function, so this is your 1, this is your 2, this is your 4 and this is your 7. I already told you how to get the min terms or max term from a truth table. You have already seen this. So by observing this, where the output is 1, the input combinations are 1, 2, 4, 7. 1, 2, 4, 7. So this is 1, 2, 4, 7. I hope this is clear. So this is what all about your XOR and XNOR. We have understood each and every property of this, and certain interesting questions we have already answered. In the next video, we are going to see something else related to logic gates.